Hello, and welcome to the Master Trainee Rigging Safety Module. This training class is for people who have advanced past the basic rigger level and are ready to gain a more thorough understanding of rigging and lifting. This Level 2 class will focus more on calculating angles and tension in slings and chains. These topics are extremely important. If the capacity of rigging equipment when used at angles is not properly calculated, injury, death, or failure of rigging equipment could result. Rigging equipment should always be inspected prior to use on each shift, and as necessary during the day to ensure that it is safe. Defective equipment shall be removed from service. Load charts, such as this one for grade 80 alloy chain, will become very important and useful references for you while you are rigging for lifts. When using choker hitches, you should always pad the corners of the material being lifted. When wrapping slings around beams and other supporting structures, it is important to pad any sharp edges to prevent tearing or damage to the sling. Chokers can be cinched down too tight. This greatly reduces the angle and therefore increases the load on the choker hitch. Keep the choker hitch loose around the equipment. The picture on the left shows a choker hitch cinched down too tight, while the one on the right is considered acceptable. As you can see in this diagram, as the angle of the choker hitch decreases, the capacity of the sling decreases as well. A basket hitch is a commonly used method for lifting loads. An advantage is having double the capacity of a single leg lift. To prevent the load from slipping, you can wrap the sling around the load twice if feasible. This will help secure the load. Whether using wire rope, chains, or slings, the angle created by the legs in a basket configuration must be accounted for. As the angle between the load inside the basket and the leg decreases, the capacity of the wire or sling decreases as well. It is important to note that the capacity is listed as a percentage of a single leg, which means even in a basket configuration with 30-degree angles, it would be equivalent to lifting with a single vertical leg sling. Here's a diagram of a vertical leg sling. A choker with an angle of 120 degrees has 80% the capacity of a single leg sling. In a basket configuration, the capacity is 200% of a single leg if the angles are 90 degrees. So if a single leg is rated to 1,000 pounds, then the maximum load it could lift would be 2,000 pounds. At a 60-degree angle, the maximum load that could be lifted would be 170% of a single leg capacity. So if the single leg was rated to 1,000 pounds, then you would multiply 1.7 by 1,000 and see that the maximum load would be 1,700 pounds. You should always try to avoid rigging with any angles less than 60 degrees. The same principle applies at 45 degrees and 30 degrees. At 30 degrees, the capacity is the same as lifting with a single leg. If you have a 2,000 pound load and slings rated to 1,000 pounds on a single leg with 30-degree angles, you would need to have 2 slings to lift the load. Otherwise, you would be exceeding the capacity of the sling and would be at risk of causing the rigging to fail. Spreader bars are a great tool to help you control angles and create vertical lifting points as shown in this picture. To calculate the load placed on each leg of the sling, you can also use this method. First, you need to know the weight of the load. Then, you need to figure out the angle or approximate angle created between the load and the sling. If you are estimating the angle, always estimate lower to build in extra safety factor. Then you can reference a chart such as this one, which has the load angle factor on it. You would then multiply the load angle factor by the load weight, divided by 2, or the number of legs. For example, if the load weighs 1,000 pounds and you have a 45-degree angle, the load on each leg would be 1,000 divided by 2 times 1.414, since that is the load angle factor for 45 degrees, which results in 707 pounds. This slide shows another formula which will yield the same results as using a table. It may be helpful if there is no table readily available for use. You would have to know the length of the sling, the height from the top of the load to the meeting point for the slings, the weight of the load, and the number of legs. This will tell you what the weight should be for each leg, assuming the load is evenly balanced. To build in a safety factor, you should always calculate the tension assuming only 2 legs are supporting the load, even if you are using 3 or 4. If not precisely balanced, any additional number of legs beyond 2 will only act to balance the load. By assuming this, you are building in an additional safety factor. A quick way to determine if your angle is greater than, equal to, or less than 60 degrees is to lay the sling across the load to the other lift point. If the length of the sling is equivalent to or exceeds the other lift point, then your angle is greater than 60 degrees. If the length is less than the distance between the two, then the angle is less than 60 degrees, and you should be concerned about the capacity of the sling and the tension created by the lower angle. To reiterate from basic rigging training module, wire rope clips such as these, and wire rope with eyes created by using saddles or fist grips, should never be used for rigging purposes. Remember, the load should always rest at the base of the hook and not on the tip. Turnbuckles can be used for rigging purposes. A load chart such as this should be referenced whenever using turnbuckles. Based on the size of the turnbuckle and configuration, jaw and eye, or hook eye fitting, you can determine what the working load limit is. A pre-lift meeting must be conducted before each lift. During the meeting, the lift plan and job hazard analysis should be reviewed. You should study the lift plan and learn to understand how to read and interpret them. You should also have a complete understanding of the job hazard analysis for lifting material. As you gain more experience, you should get to the point where you are capable of reading and implementing the lift plan and conducting the pre-lift meeting with supervision. Here, you can see a crane load chart. To read the chart, you have to determine what the maximum boom length will be used, and what angles the boom will travel while lifting the load. You must then check the weight of the load doesn't exceed the rated capacity of the boom at all lengths and angles of your lift. If it does, do not proceed with the lift. Stop and notify your supervisor. Improper loading will cause crane accidents such as this one. You must be able to account for all conditions such as load weight, angles, boom length, and weather factors, especially wind. The operator must always be in control of a lift. He may be aware of conditions that you are not. If he says the lift is a no-go, then you must respect and honor his decision. It is not acceptable to shop around for another operator who may be willing to perform the lift. Different cranes have different operating quadrants. For mobile rubber-tired cranes, these include the sides and over the rear. Lifting over the front is not allowed unless the crane was designed for such operation. These quadrants are important because you must plan your lifts accordingly. You should never drag a load using a crane. It could cause the crane to tip over and will damage the load. The crane hook should always be positioned directly above the load. You should be wary of the wind as well. Even if it is not windy at ground level, winds near the tip of the boom will have a great effect on the capacity and lifting ability of the crane. When positioning the crane, be sure that all outriggers can be fully extended on the solid ground and that the tires are off the ground. The outriggers must be fully extended to allow the crane to operate safely and to its full capacity. If the outrigger is not all the way out, the tipping axis is greatly reduced and will cause the crane to tip over. You must identify all overhead power lines and underground vaults, pipe, etc. as part of your site survey. The weight of the cranes can crush underground pipe, and you must plan to locate the crane in a position away from all power lines. Now we are going to work on some examples. What is the load supported in each leg for this example? Using the load factor chart at an angle of 30 degrees, we can see that the load in each sling will be 2 times the weight of the load divided by the number of legs. So each sling will have 5,000 pounds of tension on it. What is the load supported in each leg in this example? Here you would take the length, 16 feet, divided by the height, 15 feet, times the weight of the load over the number of legs, which is 2. This equals 13,333 pounds. Determine the sling loading in this example. You would start by dividing the length of the sling by the height. Then divide the weight of the load by the number of legs and multiply the two answers together. Your answer for this question should be 12,000 pounds. Now a more complex example. What is the load rating in each sling for this 3-leg example? You would take the length, divide it by the height, multiply it by the weight, and then divide by the number of legs. Remember, all load should be calculated assuming only 2 legs are holding the load as a safety precaution. Your answer for this question should be 6,000 pounds per sling. This calculation is more complex because the slings are unequal length and the load's center of gravity is shifted over towards the left. We'll work through this example together. To start, write down your known variables. d1 is the distance to the center of gravity from the left, and d2 is the distance to the center of gravity from the right. SA is the length of sling A, and SB is the length of sling B. H is the height from the base of the load to the location where the slings meet. To find the load in sling A, multiply the load by the distance from the right to the center of gravity by the length of sling A. Then take the total distance, d1 plus d2, multiply it by the height, and divide your first answer by this answer. This will give you the load on sling A. To find the load on sling B, you would use the distance d1 and the length of sling B to calculate the load in sling B. Back. Now that you have completed this training module, please take the test to the side of the video. And remember that safety is always our first priority.